Hello and welcome to Papati's class. In this lecture, I'd like to talk about Newton's second law of motion, which pretty much states that the sum of the force equals the mass times the acceleration. Or you can write the equation like this. The net force equals mass times acceleration. Our units are going to be SI units. So the mass is going to be in kilograms. Acceleration is going to be in meters per second squared. In kilograms times meter per second squared gives you a whole new SI unit called newtons. And therefore, the force will be represented in newtons. Now, a couple key relationships to keep in mind when working through these problems. Your mass and your acceleration are going to be inversely proportional. That means the higher the mass, the lower the acceleration. Just think about trying to throw a bowling ball versus trying to throw a baseball. The bowling ball with higher mass will have a lower acceleration. Another relationship to keep in mind is that mass is directly proportional to force, meaning the higher the mass, the higher the force. So you can think about the force, right, from throwing a bowling ball, which has a higher mass, right, which will give you a higher force versus trying to throw a baseball. The bowling ball will give you more force. Let's work through some examples and hopefully it'll make more sense. Alrighty, in this example, they're asking how much force is needed to accelerate a 66 kilogram skier at 2 meters per second. So what equation do you think we're going to need? That's right, I thought I heard it back there. We're going to need F equals ma, or force equals mass times acceleration. So now they gave us a couple different variables. Let's identify them. The 66 kilograms is going to be the mass. The acceleration is going to be the 2 meters per second squared. This is a plug and chug equation. So without further ado, let's calculate our force. So we're going to say force equals mass, which is 66 kilograms. And this is going to be multiplied by the acceleration, which is 2 meters per second squared. And when you compute that, you're going to end up with 132 newtons. Remember, newtons is the SI unit derived from multiplying kilograms and meters per second squared. Let's work through another example. In this equation, they're asking what is the acceleration of a 50 kilogram object pushed with a force of 500 newtons. So of course the equation we're going to need is force equals mass times acceleration. However, we're going to have to rearrange this equation because if you notice, the question is asking for acceleration. They're not asking for force. So when we rearrange this equation, if we divide the mass by both sides, we would get force divided by mass equals acceleration. So this is the equation that we're going to use here. So let's identify our variables. The 50 kilograms is going to be the mass, and the 500 newtons is going to be the force. So let's plug and chug here. So I'm going to say acceleration equals our force, which is 500 newtons, divided by 50 kilograms, which is our mass. And so when you compute this, you're going to end up with 10 meters per second squared. Let's work through another example. Alrighty, in this example, let's say a force of 250 newtons is applied to an object that accelerates at a rate of 5 meters per second squared. What is the mass of the object? Of course, we're going to be using the famous equation force equals mass times acceleration. However, we're going to have to rearrange this equation for mass. So that means we have to divide both sides by a, our acceleration. And when we do that, we can see that force divided by acceleration equals mass. And this is the equation we'll be using to solve the problem. So now let's identify our variables. They say that 250 newtons is applied. So newtons is what? That's right, I thought I heard it back there. Newtons is going to be our force. So 250 newtons is going to be our force. Now they also say that it's going to accelerate at a 5 meters per second squared. 5 meters per second squared is going to be our acceleration. So I already have the variables I need to calculate the mass. So now let's plug and chug. We're going to say mass equals our force, which is 250 newtons, and we're going to divide that by the acceleration, which is 5 meters per second squared. And so when we divide 250 by 5, we're going to end up with 50 kilograms. And that will be the answer. Alrighty, it's now time for a pop quiz. So the question of the day is, a force of 20 newtons acts upon a 5 kilogram block. Calculate the acceleration of the object. Pause, take a break, and we'll go over the answer shortly. So let's go over the problem. It'll be option A, 4 meters per second squared. Option B, 8 meters per second squared. Or option C, 2 meters per second squared. So if you guess option C, 2 meters per second squared, unfortunately that's not the right answer. What about option A? Option A is the correct answer. So let's go over it. So let's first identify our variables. A force of 20 newtons. Well, that's obviously a force. And a 5 kilogram block. Kilograms. That's our mass. So they already gave us our force and our mass. And if we're using the equation force equals mass times acceleration, we can rearrange this equation like how we did in earlier problems, right, for acceleration. So acceleration is just going to equal force divided by mass, right? And we know our force and we know our mass. So this is a plug and chug equation. Let's calculate the acceleration. So acceleration is going to equal our force, which is 20 newtons, divided by our mass, which is 5 kilograms. And therefore, we end up with an acceleration of 4 meters per second squared.